Hello everyone. So in this video we will be looking into a problem maximum sum subarray, and we will be looking into a specific algorithm which was provided by Cadence to solve this problem. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here in this problem we are given with an array with some random elements, and it can have negative elements as well. We name it usually maximum subarray sum. So here in this problem, what we actually do is we try to find any subarray such that if we do the sum of the elements of that subarray, and whichever is the maximum sum, we simply find that out. So for example, let's say if I take these two elements, so a subarray is actually a smaller piece of array of the bigger array, and the elements are contiguous. So if we do sum of these two elements, we will get 7. So this is one such subarray. One property of subarray is that it should be contiguous. So for example 2, we can't take 2, 4, 5, do their sum and find the maximum sum because 3 is missing. So a subarray is actually a smaller array which is contiguous. So here we saw that one of the subarray has sum to be 7. Now there can be multiple subarrays. So we need to find the maximum sum of any particular subarray, and we simply want to return that sum. So here you can see if we take this subarray 4, 3, minus 2 and 6, we will get 4 plus 3 minus 2 plus 6. So it will give us 11. So this is one such sum. So we try to find that whether this array has any other subarray whose sum is maximum or not. So here if you see, if we take these three elements, 7 plus minus 1 plus 6, so it will give us 12. So it means we can discard this sum and this would be our answer. So 12 is the maximum sum of any subarray. So in order to find such sum, the brute force way would be that we try to create each and every subarray, we do their sum and we see which is the maximum sum. So usually this approach is not good. So there is one such algorithm which was provided by Cadence, which actually traverses this array once and figures out what is the maximum sum subarray. So here how we actually solve this problem is we usually create two variables, current max and the best sum or maximum so far. Now what these two variables denote we'll see later, and this algorithm we try to traverse from left to right. So at the start we encounter 4. Now what we do here is, let's say if our array had only one element 4, so the maximum sum would have been 4 only, and we would have written from this array saying that 4 is the max sum. So here you can see we will be traversing this array one element at a time, and let's say at this index, for example, we will be storing two things, current max and the max so far. So what these two variables denote is that at index 3, what is the current max sum, and as we have traversed this array, we would have encountered many subarrays. So among those subarrays, what's the max so far or what's the best sum. So these two things we keep track while traversing from left to right. Also when we traverse the elements one by one, at each element, the element usually asks two questions, that should I become part of the current subarray which will give us the maximum sum, or should I start my new subarray? So here we'll look into the demonstration and what these two questions actually mean. So here if you see at the start, we encounter 4 at index 0. So 4 will ask that should I become part of the current subarray. So here if you see current subarray is empty because there are no elements, as this is the first element only. Should I become part of the current subarray so that sum is maximum? So at the start, both these questions, as there is only single element, both these questions correspond to the same thing. If 4 becomes part of the current subarray, it would be something like this. Or if 4 starts a new subarray, it would be something like this. So usually at the start, the current max is 4 and it has been formed by this subarray. And we simply take 4 as the max so far being formed by this subarray. Now we'll go to the first index. So at this index 3 will decide should I become part of the current subarray. So here if you see current subarray is 4. So if it becomes part of the current subarray, so subarray will become 4, 3 and sum will become 7. Or it will decide that should I start a new subarray. So if it decides new subarray, sum will become 3. So among these two questions, 3 will see that it's better to become the part of the current subarray because we are getting a maximum sum among these two sums. So 3 will become part of the current subarray. So the subarray will go something like this. These two elements are there and the current max at this point would be 7, which is being formed by 4 and 3. So here you can see now this max so far, this 7 is greater than 4. So this max so far will be updated to 7, stating that it has been formed from the elements 4 and 3. Moving ahead, now we encounter minus 2. I'll just remove this. So minus 2 will think should I become part of the current subarray. So if it becomes part of the current subarray, the sum would be 7 because 7 is the sum of the current subarray plus minus 2, which will give it a value as 5. Or it will decide should I start a new subarray. So if it starts a new subarray, the sum will become minus 2 because we will be discarding this subarray if we are starting a new subarray from here. So minus 2 sees that okay, if I become part of the current subarray, the sum will be 5 and if I start my own, we get minus 2. So it's better to go with the current subarray and get the sum of 5. So here at this position, the sum will become 5. It has been formed by 4, 3 and minus 2. And this 5 is actually smaller than 7. So max so far will remain this only. It means that though we have taken up minus 2 into this subarray, but the sum is not actually greater than the maximum sum so far or the best sum. So the best sum will actually remain this. So let's say if we had only this 3 elements in the array, so the current max would have been 5 and our answer would have been 7, stating that we usually take 4 and 3 and we will get the max sum. We will discard minus 2 from the best sum. And also here one question arises why we are taking minus 2 into the consideration here. Why we are actually adding minus 2? Because there could be a possibility, let's say the current number here is 6. So there could be possibility here number is 1000. If we don't take minus 2, then our current subarray will start from this because the subarray is contiguous, and if we are not taking any element, it means we are discarding the previous subarray. So the sum would have become 1000 if we have not included -2. And now if we include -2, so here you can see the sum came out to be 5, and let's suppose here would have been 1000. So we would have included 1000 also and got 1005. So which is much way better than 1000. Therefore we simply include -2 based on these two questions, because we are not sure what comes after this -2. It could be any negative value or it could have been any maximum value. So it's better to include -2 into this subarray. So now our subarray reaches like this, that it has included everything 4, 3 and -2. I will remove this. So now we encounter 6. So here 6 will decide that okay, should I become part of the current subarray? So if it becomes part of the current subarray, so the sum will become 5, because the sum is 5 plus 6, which will give us 11. Or it decided should I start a new subarray. So if it discards this previous subarray and starts a new subarray from here, so the sum will be 6 only. So the element 6 will decide okay, I will go with the current subarray because this gives the maximum sum. So here the current max will become 11, which will be the addition of these 4 elements of the subarray. So now here you can see that this 11 actually beats 7. So max so far will take the maximum sum as 11 because it will figure out that okay, now I need to include 4, 3, -2 and 6 together because this is giving me a maximum sum. Moving ahead, I will remove this. So now 6 has become part of our subarray. Now we encounter -12. So -12 will decide should I become part of current subarray. So the current subarray is this. So 11 plus -12 will give us -1. Or it decides should I start my new subarray. So if it starts its new subarray, the sum would be -12. So -12 sees that okay, -1 is greater than -12. So it's better I should become part of the current subarray. So here now our current max become -1 being formed like this. But this -1 is very much less than 11. So max so far will remain the same. That let's suppose if our array would have ended here. So the answer would have been 11, which is being formed from the elements 4, 3, -2 and 6. So this is the significance of max so far. It keeps the track of the maximum sum of any subarray so far. So I'll just simply remove this. And here -12 comes with the current subarray. Now we encounter 7. So 7 will ask should I become part of the current subarray. So it sees the current subarray is this and its sum is -1. So -1 plus 7 will give us 6. Or it decides should I start my own new subarray. So if it starts its own new subarray, it has to discard this subarray. And if it starts a new subarray from here like this, so the sum will be 7. So this element thinks that okay, I should not go with the current subarray because it is giving us sum only 6. But if I start my own, it will be a maximum sum of 7. So here is the critical step where the current element decides that okay, I won't go with the current subarray, I will start my own subarray, which is a new subarray. So here we simply discard this subarray because current max will now be 7 and it will be formed by only digit 7. But this 7 is less than 11, so the max so far will remain the same. So now this subarray is actually discarded and a new subarray will start from 7. So now we encounter -1. So -1 decides that okay, should I become part of the current subarray? So 7 plus -1 will give 6. Or should I start my own subarray? So the sum will be -1. If it starts its own subarray, so it decides that okay, I will be part of the current subarray because it is giving me a maximum sum. So here now our current max will become 6 because -1 has decided to go with the current subarray. 7 comma -1. Okay, but this 6 is less than 11, so our max so far will still remain the same. Moving ahead, so now our subarray has two elements, 7 and -1. So now the last element comes, which is 6. So 6 asks, should I become part of current subarray? So 6 plus this 6 will give sum as 12. Or should I start a new subarray? So if it starts a new subarray, the sum will be 6. So this 6 decides that okay, I will go with the current subarray because it is giving me a maximum sum if I compare these two values. So here, now current sum will become 12. 7 -1, 6. So this will be included like this. And now here you can see 12 is actually greater than the max sum so far. So max so far will see that okay, I need to now discard this because we have found one more subarray whose sum is actually maximum from the current max so far, which is 12 formed by 7, -1 and 6. And here there are no more elements left. So the answer would be our max so far, which is 12. So this will get written. So friends, in this video we saw that how we can solve the maximum sum subarray problem using Cadence algorithm. In our next video, we will actually see the demonstration of the algorithm step by step, that how we can use the code and come up with this logic. We will see it via an animation in our upcoming video. I hope you must have liked this video, and in case if you are new to my channel, then please subscribe to my channel. Thanks, have a nice day.